So quick recap, we talked about how oxidation is considered loss of electrons, different slide, right? But it's considered a loss of electrons, gain of oxygen, or a loss of hydrogen, right? So reduction, being the polar opposite, is considered gain of electrons, loss of oxygens, or gain of hydrogen, right? Just straightforward, kind of like. Now, it's good that you understand why it's considered a loss of oxygen and a gain of hydrogen, but for practicality, or to be pragmatic in your exam, right, you have to kind of memorize this, so to speak. I don't want to be the guy enforcing this, but it's just sometimes easier to, kind of memorize these. All right, one more time. Reduction is considered gain of electrons, or a loss of oxygen, or a gain of hydrogen. Exact opposite of what oxidation is. Ergo, reduction is really just the opposite of oxidation, where oxidation is loss of electrons. If you remember oil, right? Oil is loss, right? Reduction is gain of electrons. Simple as that. Let's move on. Here we see that copper losing an oxygen is undergoing reduction. Over here it has oxygen right next to it and it loses it. Now it's undergoing reduction because that oxygen is gone away, right? And this example is really good because you can even see that the hydrogen on its own is gaining an oxygen, so it can be considered oxidation as well. Now, you should pause the video at this point and also go over what's happening to the charges and reinforce that is it really reduction in terms of electrons, figure out if it's really reduction taking place here, or oxidation, is it really oxidation taking place here, and just confirm that. It'll go a long way if you do it right now. Okay? So pause the video, do it right now, and we'll continue. Continue after you've confirmed it. Here's another example where hydrogen is oxidized by gaining hydrogen, but look what's happening to oxygen, where it's reduced when it absorbs hydrogen. So even though these are part of the definition, they're not they're still part of this exchange of electrons idea. So oxygen can undergo reduction and hydrogen can also undergo oxidation, straightforward, right? Let's move on. Another name for burning is combustion, and combustion is a redox reaction because oxygen is gained and oxygen itself, when it's gained, is also reduced, right? Any chemical burning in air reacts with oxygen to oxidize and is oxidized to form an oxide. So it is a redox reaction, right? Rusting is also a form of oxidation. Rusting is any metal reacting with slowly. It's a very different reaction, but essentially an oxide is formed as well, right? So here is how you should start categorizing set of reactions in your head. Now there might be an overlap, that's fine, but here is a sort of tree diagram, all reactions that could take place, all reactions that could are ever possible, all reactions. So a huge branch of all reactions is what? Set of redox reactions. Oxidation and reduction taking place. And a subcategory of these reactions could be, or further classification if you want to do it, are combustion. Combustions are considered redox reactions, like the slide is saying. Or the process of rusting is also considered redox reactions. Rusting is also known as, in more technical terms, as oxidation, quite literally. And it's still a redox reaction. Okay. So this, and there are other here as well, which will over time we'll study, like one such a set of reaction, which is not in the category of redox reaction, is neutralization. Neutralization is a reaction which we'll focus on a lot more, neutralization, and it's not a redox reaction, right? So a big category of reactions which we see in our daily lives are classified as redox reactions just because, redox is essentially talks about exchange of electrons. Most reactions do that. Okay, moving on. Definition for oxidation and reduction. So oxidation, quite literally, this is mimicking an exam question. Oxidation is oil, right? Loss of electrons, essentially, like nothing more, nothing less. That's a satisfactory answer. And reduction, can you guess what? Reduction is considered as gain of electrons. Okay. What's really fascinating, just a little bit extra, try to figure out where the word, look up online where the word electron comes from. It's so fascinating, it's so interesting. Just give that a shot, where the word electron comes from. It comes from electricity, where the word electricity comes from. Alright, let's move on. Magnesium reacts with sulfur dioxide like this. Magnesium reacting with sulfur dioxide, where it gains oxygens and sulfur in its elemental state is present. Use labeled arrows to show which substance is oxidized and which is reduced. Now this is where our new definitions के oxygen की भी हम बात करते हैं, hydrogen की भी बात करते हैं, is really important. Normally we'll have a hard time figuring out यहाँ पे oxidize कौन सा हो रहा है, reduce कौन सा हो रहा है, but we're so comfortable with the idea that oxygen will always gain electrons. We can say anything gaining oxygen is oxidation. So magnesium ends up gaining oxygen, so this is my oxidation taking place right here. Can I confirm it? Oxidation, right? Can I confirm it using the charges? Yes, I can. It has a 0 charge over here and a +2 charge over here. Sulfur is losing oxygen, and loss of oxygen is considered reduction every time my speaker starts up. Right? This is considered as reduction. Okay? And we can see that sulfur currently has a charge of +4 and it's now 0. So +4 to 0, it gained 4 electrons and underwent reduction, gain of electrons. Okay? Let's move on. I need to show this is a redox reaction. How do I do that? Well, I highlight where carbon is, either I can do it in terms of the charges, but it's kind of easier to talk in terms of oxygen. So it's not only losing hydrogen, which is in itself oxidation, but it's also gaining oxygen, which is double oxidation, right? Like there's also a degree, something can oxidize more than other things, and that quantifying element will come in the following lectures, but it is there. Something can oxidize more, so to speak, than others. It's a quantifiable thing. If it loses more electrons, it's being oxidized more, essentially. This is oxidation. And oxygen, not hydrogen, is being a little bit extra reduced. Reduction. When oxidation and so if you had to solve this or comment on this furthermore, and if this was a exam question, you literally say carbon and methane is undergoing oxidation, and oxygen reacting with methane is undergoing reduction, right? After that, you mention that as both reduction and oxidation are taking place, therefore this is a redox reaction, because redox reactions again are just reduction and oxidation taking place at the same time.